Okay. First of all, Happy New Year. I'm happy that you find your way to the lecture today. So, what are we going to do today? We will have a lecture on economics of school education, and we will discuss with you the concepts of education production function, which is similar to the concept of production function you studied in general in the course of microeconomics, I hope. Yeah. So today we have only one presentation due to the sickness of one of the other presenter. And today we're going to discuss with you education production function, economics of class size, also how family background might affect education production function, peer effects in education, and school tracking. Yeah. I would probably suggest that we start with Hannes, who will present the paper on school tracking, actually, and then we can proceed with the lecture. Okay, so the floor is yours.
So you can use your
laptop
and stuff.
You can feel like you have a lecture today, and yeah. Why it's not? It doesn't run. Okay, the floor is yours. We can change sides.
Can I change the, how can I go?
There is a keyboard there. The keyboard. Yeah.
This one, I can just, yeah, okay.
Or you can just put this backspace or.
Yeah, I only need to go in one direction, but now I.
Yeah, it's like this.
Set up. Yeah, okay. Perfect. Yeah. Okay. Yeah, perfect. So, like already introduced, I will do a presentation. I will show the paper that I was assigned to, or that I assigned myself to, which is Does Educational Tracking Affect Performance and Inequality? And I think it's really nice to understand the topic because we all have experienced tracking. Tracking means assigning students to different school forms after primary school, like Realschule, Hauptschule, or Gymnasium, but I will explain this later on. This is the empirical approach with the difference model. Really, like we have also discussed in the tutorial, also nice to understand, you will see it afterwards, was published. The paper was published in 2006 in the Economic Journal, and it's by Eric A. Hanushek and Ludger Wassmann. Okay, so just some quick words to the agenda. I will introduce you to the topic, then I will say why is it relevant, why is it for us relevant, and why is it socioeconomically relevant. Also, I will give you a quick overview of the current research concerning this topic. Then we will talk about the data, because data is important for the methodology. The methodology, I already revealed the difference models that I will explain. And then, of course, we will look at the results of this difference model to then later on come to policy implications and a conclusion. And then we can discuss this topic. First of all, introduction. The research question is, does early educational tracking affect students' average performance and the inequality of educational outcomes? So, in how far does the assignment of students to the different tracks affect their academic outcomes, so their performance, and in how far does it affect equality? What kind of study is this? It's a cross-country empirical analysis, and we use a difference approach. And I can already reveal this. We compare students in countries that don't pursue this tracking thing, such as the USA, two countries where tracking, where there is tracking in the economics, in the educational system, such as Germany, and then we look at test results and see in how far does the tracking affect the outcome of these tests. For you, what do we expect? We expect that the difference analysis is going to show us that the tracking increases inequality and does not significantly or does not at all increase the performance of the students in the tests. So we suggest now, or the author suggests in the beginning, that tracking is rather seen negatively when we look at the performance and the equality in the education system. Now relevant to topic, I've already talked about it to some extent, and I think if you follow media, you see really often the discussion, is tracking good? Is it good for performance, for academic excellence, or is it more pushing inequality and being negative for the students' performance outcomes? So I think the socioeconomic relevance is quite clear in this case. Also the related literature, there is some research been made. Also my paper is not the most, it's quite old, and there's probably even more research, but especially this cross-country analysis can be seen as interesting, and also the difference approach was at this time when the paper was published quite good for the analysis, especially seeing that a lot of papers have focused on the intra-country analysis, and also there have been some statistical barriers such as omitted variable bias in some other papers. So that's why we can say that the analysis is definitely still relevant in 2005, but also in 2025. That's it for why is it important that we look at tracking. Now we can I go back. Wrong. Now we can look at the data. Like I said, we use difference approach. So for a difference approach, we need data that serves to give us the treatment group and the control group, and this is why our data sets are the results of different tests that are being made in all the countries. I think you all know the PISA test. It's a test where the students are being tested on their competences, and it serves to measure in how far their education or in how far they perform in different types of tests, such as reading and mathematics. And this is the data that we use also for difference analysis from different countries. It's a repeated cross-sectional country level data, and it's important that we do not use panel data. So we are looking at the students and different students every time we look at the data. Panel data would mean that we follow the same students for more years. In this case, now we are looking at the test results of different students each year, but it's not the same students. That's really important to understand. And then we look at their primary school and lower secondary school, so pre and post tracking, and our most important data are the test scores in reading, mathematics, and science. Now I just want to quickly explain in how far does this serve to give us the control and the treatment group. Like I already said, tracking is not applied in all countries. In the USA, we have the high school system where the students are in the same school type for multiple years and are not assigned to a different track, whereas in Germany or Austria, for example, we are in the primary school till we are maybe 10 years old, and based on our performance in the primary school, we get assigned to a Hauptschule, Realschule, or Gymnasium. And this is then the natural experiment which serves to give us the control group. So countries like the USA, the test goes from there, and the treatment group, test was from Germany, for example. Now we can look at the difference analysis, and we're looking at two different things: the mean performance, so the performance of the students, and the inequality in performance, so which is the distribution of the test scores. And to not give you the whole I gave you both of the regression analysis. Really important for us is our Y, the mean test score in the specific country, and the difference estimator, which is, I don't know the name of the variable, but it is the thing before the track. And what we are trying to look at is in how far does the difference estimator, so tracking or no tracking, has an influence on the test score outcome. And we will see that later when we look at the regression table. It's basically the same thing that we did in the tutorial, where we looked at the difference estimator and how far it influenced the outcome of the regression analysis. Also important that we don't try to predict anything, but we look at the difference estimator track and how far it has an impact on the test score. This is what we try to look at. I hope it became kind of clear. Yeah, obviously in the control group, the difference estimator is 0, where it has an impact in the treatment group, like always in the difference model. So now we can look at the results, and I will start with the distribution of outcomes, and we can see that we have a statistically significant positive impact of the difference estimator on the inequality measure, so that if there is tracking in a country, that we have a broader distribution of test outcomes, meaning higher indication for inequality. For the mean performance, which means the efficiency or the performance of the students, we have not so strong, statistically significant at the 10% level effect, which is negative, slightly negative. This is important because it shows that the tracking, which is there to pursue educational excellence or push the test scores of the students, does in this case not have a positive impact on the test scores. So the performance overall is not better. It pushes the inequality, but it's not better for the overall performance. And this, in the end, shows that tracking can be questioned in this case, because, like the analysis has shown, it does not have a positive impact on either of the measures that we did. Also, the pooled estimate means that we, in my presentation, I do not show you the impact on each and every test score, but the author gives us a pooled estimate, which is much easier to present here and which summarizes the test scores and the effect of it. Yeah, this would be it for the analysis, and now we can come to a conclusion, and I already said it, the early tracking seems, or after analysis we can say that it increases inequality in education outcomes without clear efficiency gains. So yeah, policy should maybe question this type of tracking and assigning students to different school types earlier, because it seems to not have a positive impact on the students' academic outcomes or equality. And this is also where I can give a question to you, because we have all experienced the tracking. We've been to Grundschule and then been assigned to Gymnasium, Realschule, or Hauptschule, or maybe also Gesamtschule, which is the mixture. And I want to ask you, how did you experience the tracking based on your own educational path or that of your friends maybe? So what do you generally think about the topic, looking back at your school time maybe?
Okay. So thank you for the interesting presentation. Yeah, it was a very good presentation actually. Yeah. So just, I'm not sure, like, who of you went through this system? No one.
Okay,
Yeah, that depends, but I mean sometimes it's not very relevant given that yeah, we have some international students as well, or like those who started schooling a bit, and for me as well.
You're also not into
No,
okay.
but no, I have some
Okay.
questions for you as well. So any questions to the presenter? No. You can think because I have a lot of for English speaking. So okay, so you discussed the effect of this early tracking on outcomes, but what could be the potential mechanisms of how tracking might affect student outcomes?
Yeah, so the argumentation for tracking is that that you're assigned to track basically performance. So good performing students are with good performing students in a different school form, such as the gymnasium. And so it's more pushing, I would say, like academic excellence. So good students are with good students and the peers are with each other, whereas the bad students, and not the bad students, so the low performing students are in one class or track where the teacher can give them their different needs for their education. And in Germany we say that, or people say that mixing the students leads to the not so good performing students bringing down the better students.
Okay, so we call it peer effects.
Peer
and we will
effects,
discuss it in the lecture today as well. Yeah. Okay, good. And could you please return to the slide with the formal model? Yeah. Okay.
Yes.
So if you remember from our tutorials, normally our difference estimator is an interaction term between treatment and before-after period. As you can see here, there is no interaction term, there is just a treatment. Why is it so? Any ideas? Just think about what is estimated and what is like before and after period.
I'm not sure.
That's a difficult question.
I'm not so sure.
It's fine. Okay, so the idea is that because you use a pooled model, and it is measured for many years, you don't have a standard two-period model in difference when you have period before period and period after period. This means that like you kind of estimate the fixed effects of time fixed effects, and that's why you don't have a interaction term with before or after period, because this is not just a single like before or single after, because you have so many things. Yeah. Okay. Any questions from you? No. Okay, then Hans, thank you so much for the presentation. Perfect timing. So I would say it's very good. One little comment: it would be nice if you could also kind of consider the strengths and weaknesses of the paper and point out what could be what can you criticize in this paper as well. So I don't know if you are ready to answer this question, or if not, it's fine. But I mean, in general, it would be like.
I mean, for me, which is maybe could be a problem, is that we are looking at it based on the test scores, and I think maybe the cross-sectional repeated data is not perfect to really measure whether tracking is good or bad, because for that I think panel data would be better to follow the students, and especially if we talk about peer effects, it has much more impact than on the test results, because in the gymnasium you're with peers that have maybe different ambitions than others, and this can push your academic career. So maybe my critique would be that we should include panel data in order to really...
Good question. Then, why they don't include the panel data? What about PISA test do you know from the lecture material? At what age or who is surveyed there? Gefei, I think you prepared a presentation on that. Do you remember at what age?
Yeah, like high school and the middle school. And
yes, but so actually the thing is that they are surveyed at the age of 15.
yeah.
And you cannot have a panel data because like each
Yeah.
year you survey only individuals with the age of 15. You cannot be 15 many periods, right?
No, of course.
That's why just for this particular research question panel data is not feasible. Otherwise, of course, it could be used, right?
Yeah.
Okay. Yeah. Thanks again.
And I still have a question like how that be called actually in Germany in German?
The tracking.
Yeah.
There's not really a name for the tracking. It's just in Germany. After fourth grade, you get assigned to a school form, which can be like Hauptschule, Realschule, and Gymnasium. And like classically, which is not a thing that I'm a fan of, but the Hauptschule was more for workers. The Realschule was for higher skilled workers. And if you go to Gymnasium, this means that you are trying to pursue an academic career. And the critique would be that these are students of 10 years maybe, and it's a bit early to decide what kind of path their life takes. But there's not really a name for the tracking.
Is there any other countries like in European and like other European countries would also apply this kind of measurement, or is that only in Germany? Or
no, it's also in Austria. It's a really common thing actually in Europe. I don't know all the countries, but it's really common. But I have to add that Germany is pushing the general high school system, which is called Gesamtschule, more and more, where all these are included. So we are also like, there are more and more high schools, like in America, I would say, where the tracking is intra-school. So it's not 3 different schools, but you are all in the same school, and based on your performance, you get assigned to a plus course or a plus course. You know what I mean? Yeah.
but sorry, last question. And but is that fair? For example, like equal for the all type of schools. For example, like Gesamtschule, like Gymnasium and etc. And they all have this kind of tracking system. And is that standardized in the sense of different type of schools? And do you think that in the study have they mentioned about this point?
You mean in this study?
In the study about the generalized tracking system, and whether their study and about their effect and impact towards different type of schools like Gesamtschule and the Gymnasium and different types, whether this is generalized applicable.
I think it's automatically included in the analysis because all the students of 15, for example, they participate in the PISA test, so it's all automatically included, I think. But it's not distinguished between how far the gymnasium people are performing. There's not a specific analysis for this, but it's all included in the analysis because we have included them in the data.
Yeah. Okay. Thank you. Yeah, I mean it was a very good presentation, which is nice. Okay. Yeah, given that we have a kind of a treatment and control group with this audience as well, maybe it's worth discussing what might be the advantages and disadvantages of this early tracking. Because for me it seems quite ridiculous that at the fourth grade you already kind of your further educational and labor and career path is kind of determined, because I think what Hannah didn't mention, but it's also important, that in Germany, as far as I understand at least, you can be admitted to university only after you graduate from gymnasium, because you need Abitur, right?
Yeah, you can. I mean, there's like a second track you can choose can go to Realschule, and after, because Realschule finishes at 10th grade,
Yeah, you
and then
can switch to.
or you go to Gesamtschule, but it's really ridiculous. Also, concerning that it's the teachers who decide. It's not a standardized process based on your grades. The teacher decides, and there is a discussion that suggests that teachers they also see that kids with academic, with parents who studied, for example, have a higher chance of being good at gymnasium, and so they send them to gymnasium even though their grades might be not that good. So it's even not fair because it's subjective. It's really ridiculous.
Yeah, exactly. So guys, do you think there might be some, what advantages of like non-tracking system do you see where you studied? Yes.
I think that more to speak that in individual level can improve the subjective working ability, for example. And if, for example, this kind of tracking system exists, and then some peer effect could destroy the confidence, for example, like for students, and sometimes they react differently and have the different production function in their study and etc. If for example, generalize this kind of tracking system and some individual effect were not included, and so this could also be considered into, but yeah.
Okay, thank you. Vladimir?
I would say maybe the positive point of tracking could be like matching instructional or educational content to the student or to the kid in this example of like somebody who's like more inclined to study. You know, maybe it's better for them to go to
to study with stronger students, right?
Yeah.
But so
That's like very good.
maybe it makes some sense, but I think it would be nice to have this kind of tracking a bit later, because at the 4th grade it's really strange. Currently, actually, I work on the paper on the school entry cut-off date and like its effects on further outcomes. And it seems that many parents are afraid of admitting their children to school earlier, because they're afraid that at the 4th grade they will show worse results than their peers who started school later, and that's why they tend to postpone this school enrollment. And in general, in Germany, compared to many other European countries, the age of school graduation is very high, so you're really much older than in many other countries. And also, I think if they ask in which European countries this tracking system works, so I would say this is mostly former German Empire, Austro-Hungarian Empire. It's like some kind of legacy, and probably, but I'm not sure, maybe in some Scandinavian countries, but I'm not sure about that. So I know for sure it's in Slovakia, in Austria, in Germany, but maybe in some other countries as well. Yeah, but not that many countries. But Hannes is an expert now, because I read the paper of Hannes and Bösman like 5 years ago. So it's like it has been a while. Okay, let's talk today about education production function. Yeah. So the idea is, like in economics in general, as a firms, which you studied in microeconomics, so schools also use scarce resources to produce learning outcomes. So if firms produce some output, like goods or services, school produces kind of knowledge or student academic performance. And central policy questions are which inputs might matter for student academic achievement, how large are marginal effects of different outputs, and how the budget should be allocated across different inputs. Yeah? And why education production function is important? Because it can provide kind of a language which is relevant for theory, empirics, and policy. Because theoretically, it can map inputs into educational outcomes. Empirically, what is also very important, education production function provides you with tools to estimate quantitative how different inputs might affect the outputs in education system, and for policy it's also relevant to cost effectiveness analysis and various trade-offs. So education production function is a process by which educational outcomes such as cognitive ability or knowledge are produced from different educational inputs. Then the key question is, what are the inputs and outputs of education production function? What do you think? What might be the inputs of education production function? What produces skills and knowledge? Look at this auditorium.
Teaching.
Teachers, right? So this is one input. So it's just, do you remember how production function in economics looks like? What it consists of? Yes, Vladimir?
I mean, why?
Yes, okay. And what are the inputs?
But doesn't it like depend on the function itself?
But in general, I mean, there is a classical Koch-Douglas function.
Yeah, alpha plus y plus x.
No. Come on, it's like, okay. I haven't studied microeconomics for a while, I would say, but I mean the kind of classical function, Koch-Douglas function looks like this, right? Then there is alpha or some coefficients which shows like how these factors can be substituted and how which factor is more important or less important, but in general, this is always a capital and labor. Yeah? In case of education production function, labor are, like, let's say, teachers. And what can be capital?
School materials.
Okay, so there might be some kind of school materials. Do you think is it important that we have computers, we have some beamer, you can make a presentation, whatever, so some kind of equipment? It was also nice that we are here in the university, we are not there, it's cold, you know, you don't have anything really which can help you produce the knowledge, so this means that you have some buildings as well, so educational materials, etc. So this is a kind of a classical way of showing how some inputs lead to some outputs. And we discussed with you that outputs can be something like your skills, knowledge, etc. And we know from the previous material how it can be measured. The easiest way? Yes, exactly. So some test scores. Yeah. So basic education production function looks like some test scores, indicators of your, let's say, academic achievement, is a function of like school capital and like teachers' labor. Yeah. So, and the key question is like, what can improve academic achievement? Do we need more capital or do we need more labor? Will it be more efficient if today, instead of me, there will be also me and young moms? Right? Or maybe you will have a third teacher as well. Or would it be more efficient if you will have like, I don't know, not one screen, but instead of two screens? So this is how it works. So for this particular class, it's quite ridiculous because, so I think it's not really good that we have like courses with 7 students. I understand it's specialized, it's also master program, it's fine, but yeah, personally I would say that like our student-teacher ratio is very, very high. Yeah, because you have 1 teacher per 3 students, which is like, I don't think it's optimal, right? Okay, so this is what education production function is about. So, yeah, inputs are factors which are used in the process of production of education. So they can be any factors or resources that contribute to building individual cognitive ability or knowledge. So we discussed that. And standard measures of output of student achievement are some standardized test scores. They can be grades and assessment, and also they can be also kind of important, some promotion or completion indicators. For example, time to degree. How much time do you spend to get your master qualification or bachelor degree, or maybe did you repeat your grade at school? Yeah, so this can be also measures of the quality of education. Yeah, but most common variable is test scores. It is widely used. We discussed it's quantitative, it's comparable, it's available at scale, so it's fine. But on the other hand, it has also some imperfections because because sometimes there might be comparability issues, sometimes it can be hard to measure it properly, and so this can be problematic. And for the inputs, first inputs are teachers. So teachers represent instructional labor, and there could be several channels through which teachers might affect learning. So, of course, explanation and structuring material, making a curriculum, course program, etc. Then also feedback and assessment is important because it's important that you get some feedback. For example, you will present your research proposals next week, and you will get some feedback from me, and then hopefully you can really improve it. Some kind of classroom management and individual support for students. And there would be several empirical proxies of how teachers can be measured. So first is a quantitative, just a number of teachers. So for example, like for us, it's, as I said, like teacher-student ratio is kind of ridiculous. So you have one teacher per 3 students. You have almost individual class. Yeah. Or there can be some simple measures of teacher quality, let's say number of publications I have, or a degree I have, do I have a PhD degree or master degree, etc. So this can be, you can measure teachers either quantitatively by numbers, or you can measure their qualification. Yeah. Then instructional capital as an input, it might include, as we discussed already there, some textbooks and teaching materials, classroom equipment, laboratories. For economics, it's not that relevant, but when you study physics or you study some other STEM fields, laboratories are very important, and laboratories equipment, ICT and digital tools. So, for example, some universities cannot afford state license, something like that, so it's important. And physical learning infrastructure as well. So capital supports instruction but does not automatically produce learning. And it's exactly like capital in the standard production function. Just imagine you have all the capital, you have the auditorium, you have all the computers, presentations, etc., but you don't have teachers at all. Like not me, not Jan Markus. So I would suggest that it's quite unlikely that you will succeed with a course on education economics. Although now we have some online courses, but still in the online courses there are some teachers who at least make a curriculum and some videos which you can watch and which can be helpful for your learning. Yeah. So then, as we discussed, there are some limited resources, and as a result, schools choose combinations of teachers and instructional capital. And it raises some policy questions. So, do more teachers increase achievement? Does more instructional capital increase achievement? Can capital substitute teachers? Are teachers and capital complements? So, what would you say, like, teachers and capital are rather like substitutes or complements?
They're complements because teacher cannot work without, for example, the computer. So you couldn't show.
And also computer cannot be held without the teacher. Yeah, exactly. So they are rather complements and substitutes. And yeah, so this, the education production function kind of formalized this trade-off. So if you remember this from the microeconomics course, so we have two axes. One is teachers. Here in this particular example, that's computers, but in general, I mean, this is all kind of equipment which can be used at schools. And there is a budget constraint here because resources are limited. And then there are isequants, and so this is the optimal point with the optimal number of teachers and optimal numbers of computers. School can choose given the budget constraints. Yeah. And downward slope implies substitutability, and isequants show all combinations of teachers and capital producing the same achievement. So this is a formal idea. Yeah. But what is most important, that we can present this education production function in like econometric analysis as well. So if you look here, you would notice that it's exactly look like a regression. So you have a y, which is your outcome variable, then you have an intercept, and then you have a number of teachers and capital as regressors, and beta and t and beta k coefficients, which are coefficients in your model. And so this beta t is a marginal effect of teachers, beta k is a marginal effect of instructional capital. So this means that, okay, I add one additional teacher, and how this marginal additional teacher will affect the student academic achievement. Yeah. Also, like I add one additional computer, and how this additional computer will affect student academic achievement. And you can kind of formalize this with the education production function. Yeah. Any questions on that? No? Okay. So, yeah, but this model is kind of intentionally simplified because in reality it ignores many things, as well as in Cope-Douglas function. So, you know, we have a capital labor, but we also have like technological progress in many models and other factors, right? So, this is similar also in education production function because it ignores family background, which will affect academic achievement. It ignores students' ability and effort. It ignores peer effects, prior learning, but it is useful for intuition. But as usual, like all economic models are useful for intuition, but they don't work in the real world. So because the world is more complicated, and there are kind of extended education production functions. So this education production function looks more real, I would say. So we still have teacher capital and teacher labor and capital, but also we have a family background, we have peer effects, and we have ability and effort. And so these three outputs kind of non-directly related to school, and these two outputs are school outputs. And so actually learning depends on both school and non-school, right? So this is a key issue, and again, it's really good that why education production function is kind of famous, because you can always present it as a regression equation. So again, you have y, which is your output, and you have several factors in the model. And you have beta, gamma, delta, and theta coefficients, which you can interpret as a marginal effect of this additional factor. Yeah. Is it clear? Yeah. Okay. But as usual, actually there are a lot of problems of empirical estimation, because in reality inputs are not randomly assigned. Because, like, okay, you hear and it seems, okay, I can just estimate the OLS regression and then estimate the effect of each factor. But in reality, there is a non-random selection, because families choose schools. Like, if schools are not equal, if you are not, don't have to go, I think in Germany you actually have to go in the school depending on where you live, right? Or you can choose.
You can also choose.
You can choose.
Yes.
And
Like
you
in
know,
Berlin, for example,
yeah.
you can go, for example, you live in Neukölln, but the schools are not good enough for you there. So there are families that choose a school in a different part of Berlin because they are better in terms of resources.
And you can choose it.
Yes.
But when there is a like of too many
Yeah,
applications,
then it doesn't. Yeah, then it doesn't work. Theoretically you can choose, but then in reality it gets difficult, I think. But I'm not sure how they do this. Then I think you need to apply, and then probably they would take the kids that live nearby and not.
Okay. So yeah, you see that actually in many cases families choose schools. So this means that like parents from like better socioeconomic backgrounds or with higher educational or cultural capital tend to choose better schools to their children, and this affect their educational outcomes. Yeah. Also, resources can be targeted to certain students, but also teachers tend to sort across schools. For example, like I'm a teacher, and I think, okay, so I have an offer from like school in Neukölln, as you mentioned, and I have an offer from school in Dahlem. So probably I'll go to Dahlem because it would be easier for me to teach there. In Neukölln, you have like more diverse background, you will spend a lot of time to adjusting the program, etc. So of course, teachers also tend to select to schools, and again, like it seems that the better teachers will go to the better schools. Yeah, and this can also bias your results, and ordinary squared may be biased due to that. And as usual, to resolve these problems, you have to use the methods which we discussed in the tutorials and the lecture on theory. So you can use randomized control experiments, or you can use some policy reforms and natural experiments for difference and difference, regression discontinuity, or IB methodology. So how RCT could work? In Germany, there is now a program which is called Strat-Chancen or something like that. So they deal with the program that there is a pool of really good teachers, like some kind of excellent teachers they choose, and there are some disadvantaged schools. And there is a universe of these disadvantaged schools from bad districts or like kind of bad districts or poor socioeconomic backgrounds, and then they randomly distribute these teachers to these bad schools. But they do it randomly, so some schools do not get teachers, other schools get teachers, but all of these schools are kind of bad. This means that you can do a kind of RCT analysis, because this is a randomized controlled trial. There are bad schools. To some schools you kind of send good teachers, to other schools you don't send good teachers, and then you can compare results before and after. Yeah? And by this you can kind of estimate the effect of teachers, for example, on school outcomes. And this is important policy measures, because, so the question is, should we kind of distribute like best teachers to the good schools or to the bad schools? It's like this gradient tracking. Do we need to have like better outcomes but segregation, or we have to avoid segregation but then our average outcomes would be worse? Yeah. But in general, the problem is, as usual in economics of education, you have to use causal methods like RCT, difference in difference, RDD, IB, so that anyone would believe in your analysis. If you use just naive or less regression, then it doesn't work. One important output in the production function is also class size. Class size is one of the most important variables. And it's not just a primitive input, because it reflects how teacher labor, is allocated across students. So smaller classes imply more teachers' time per student. Yeah. So class size and transformation of the teacher's input in the education production function. So, for example, I have my own experience. I attend a German class at Free University of Berlin. And unfortunately, we have 25 students. And still, my German is really bad, I would say. Yeah? Because if you have a larger class, this means that the teacher can dedicate less attention to each student, right? On the contrary, if the class is small, then it's more likely that the teacher can take attention to each student, and this is a problem here. Yeah. So with the class size, you can kind of rewrite the education production function. So let's say TS will be number of teachers in school S, and NS is the number of students in this school. So average class size can be rewritten by this. So class size is the number of students divided by number of teachers. So smaller classes means that there are more teachers per student, and larger classes have fewer teachers per student. So for example, our class is really small. We have just three students now. I think in general there are 8 in our course who registered for the course. Yeah, and so you can rewrite the production function in per student terms. So you have here your yi, which is still academic outcomes, and now it's a function of the class size, capital, family background, academic achievement, and peer effort. So class size affects learning through structural labor per student, and structural capital and other inputs remain relevant. And this formulation makes clear why actually class size might matter theoretically. Yeah. Again, like if we are interested in estimation of how class size affects some of your outcomes, what could be the problem? Okay, so we have here like some kind of academic achievement, and then we estimate a regression where we have class size, we have some controls. So what's wrong with this model? Why do we need RDD, ID, different D, etc.?
I think this class size is wrong.
Class
Cool.
size is what?
Is not very correct. Class size could be wrong.
You mean measurement error?
Measurement. Yeah, but it's kind of like. Yeah.
Okay, again, for the class size, the problem is the distribution of class size is not random. It's endogenous, because let's say we know the students are bad. And from policy perspective, okay, if we have bad students, we might have to compensate it somehow. And so maybe we will put bad students in the smaller classes. And then it can be kind of endogenous, yeah? Or maybe like parents who are rich might say, okay, I want my child to study in a class with only 10 classmates, not like 30 classmates, and can be kind of a private school with this number. And this is also endogenous. And so the problem is that you need to deal somehow with this heterogeneity. And that's why you cannot use OLS estimates here, which will be biased because this class size is endogenous. There is an endogeneity here. Is it clear? Okay. How can we deal with that? Actually, there have to be a presentation for that. Maybe it will be next week, but like in general, I would just say a few words. So in Israel, there is a Maimonides rule, which came from medieval age. So the idea is that Like there is a rule in Israeli public schools, when enrollment in grade exceeds some thresholds, 40 students, then the classes are kind of doubled. So let's say you have 39 students, this means that you will have 39 students in the class. But if there is 40 students at school, then they will be divided into classes with 20 and 20. And this provides a kind of random variation in the class size, and you can use regression discontinuity model to estimate the effect of the class size, because now the class size is getting random. And actually this study found that smaller classes increase student achievement, and especially the effects are stronger in the early grades when you start your schooling and for disadvantaged students. So this is how it works. But hopefully during the next class you will learn it in more details. Yeah? Family background in the education production function. So family background could be also one of the important inputs in the education production function, because it might capture resources that students bring to school before actually the instruction begins. Yeah. So family background might include parental education and cognitive skills. So if your parents have higher education, a lot of research shows that it's much more likely that you will also have a higher education. Yeah. Family income and material resources also might matter, because like richer parents can send you to better schools. You have also more facilities at home. You can have a better home learning environment. For example, you can have your kind of separate room. I don't know, in Germany it's like normally kids have a separate room, right? Or it depends on the number of kids, how does it work?
Yeah, I mean,
You're an insider here.
I would say it depends if you're from rural area or city,
Okay.
and how big your apartment/house is. I know that there are households also where two children share a room. That's not that often.
Okay, but even this is a kind of input, because
Yeah.
it might affect your learning conditions.
Yes.
Yeah.
Yes.
Where you live, how do you live, like can you do your homework, or maybe during this time there will be a lot of noise, or like you have to help your parents for the household production, or yeah, many other things. Also, do you have, for example, in Pisa, there is a question like, do you have a personal computer at home? Do you have an internet access at home? And this all might affect your learning outcomes as well, right? So, and of course, other things like cultural capital, language use, and educational aspirations will also affect your outcomes. So, for example, if your parents have an immigration background, maybe they speak some other language at home, and then maybe it will be more difficult for you in the first grades at school to understand everything in the language of the native country. So, for example, you are, I don't know, like a person with a Turkish or Russian or whatever background, your parents talk like Turkish language, Russian language at home, then it's more difficult for you to learn German maybe, and to understand German at the first grade at school, which might affect your further outcomes, right? So, and these factors affect both your initial achievement, how ready are you for the school, and also the capacity to benefit from other schooling. So family background really matters. Yeah, and so it matters because of direct effects, early skill formation before school entry, and support from homework, learning habits, and educational choices. Did your parents help you with your homework at some point? No?
Yes.
Yes?
You mean in elementary school?
Yeah, some kind of school, anything.
Yeah.
Yeah, so they help you, right? Okay, it's fine, but I mean, in some cases, the parents don't help. right? So you just don't understand everything and no one cares, right? And this affects your probability of understanding the material at school and progressing, right? So this is how its family background might affect. Also, kind of indirect parents' examples of their lives. So, for example, if your parents read books or attend some cultural events, or they tend to, I don't know, don't do it, right? So this might also, with this example, it might also affect your outcomes. And there could be indirect effects through sorting into different schools and peer effects. So as a result, family background is both individual input and a key driver correlated with peer effects, which we will discuss a bit later. Yeah? Okay. School tracking. Maybe we will briefly discuss it again with just a main concept. So in general, this is a separation of students in different educational tracks, which Hannes already mentioned. But what it's important to understand through which mechanisms school tracking might affect outcomes. So first of all, it changes in peer composition within tracks. So this is what we briefly covered. So if you are in gymnasium, you will be around students with high educational motivation, from better socioeconomic backgrounds, and this might provide a kind of positive externalities for you. But on the contrary, if you are in some kind of segregated environment with bad students, then it might also affect your outcomes. What we also have not discussed is that there might be kind of differences in curricula and instructional pace between different types of schools. So let's say curricula in gymnasium might differ from curricula in some vocational training schools, right? Because in vocational training schools you are more likely to have some kind of practical skills needed for like work as a manual labor. And in gymnasium, they are more theoretically and more academic, and this might affect your further learning outcomes. So difference in curricula and instructional pace also matter. Then teacher expectations and instructional strategies. So if teachers know that like your academic performance is not that important, maybe they will kind of structure you differently. Yeah. And also there are interactions with family background, because again, in gymnasium it is more likely that you will be around students with also relatively higher socioeconomic background, and on the contrary, in vocational schools you are more likely to be surrounded by students with a lower educational background. So tracking directly shapes peer groups and interacts closely with these peer effects. Yeah. So we don't discuss this because Hannes already presented the paper. So during this lecture we also discussed with you in detail peer effects. I mean, not in detail, we kind of covered, and now I want to discuss it in more details. So peer effects. What are the peer effects? There is also a big literature on this topic. It's not only in education, but in many other situations. For example, in banking, if there is kind of panicking in the market, there might be also peer effects. But at school, peer effects are understood as a causal influences of classmates on your or on student educational outcomes. So outcomes might include not only achievement, but also effort, behavior, educational choices. So peers are typically defined in a classroom, or a grade, or a track level. And so it's important to understand that education is not produced in isolation. It is produced in groups, right? So here we have a small group, and individual outcomes may depend on class composition and also on peer interactions. Yeah? And policies such as class assignment, tracking, school segregation might affect outcomes through peer compositions. Yeah? And what is also important that peer effects may affect educational inequality when high achieving or high socioeconomic students cluster together. So, for example, in the United States, why it's important to graduate from Harvard University? Because you might have also peers from very high socioeconomic background, and this will help you in life as a future connections, and also when you study with really strong students, that might affect your outcomes. Yeah. There are three types of these social effects. Again, estimating peer effects is quite difficult because students are grouped, again, not randomly, but at the same time they can influence each other simultaneously. And so, researchers, there is one key paper by Mansky on identification of endogenous social effects, and he identified three types of effects in the peer effect interaction. So, first of all, are endogenous effects. So, this is how your individual outcomes depend on peers' outcomes. So, example, a student effort responds to classmates' performance, creating feedback within the classroom. So this means that, okay, my effort depends on what grade received, I don't know, Hans or Vladimir or Gefei, yeah? So this depends on, like, how do I work depending on what grade do you have. They might be contextual or exogenous effect, then individual outcomes depends on peers' predetermined characteristics. So let's say if I know that I study with bad students, it might affect my efforts as well. Yeah. So classmates' prior achievement or family background shapes the learning environment and teacher responses. And there might be correlated effects where similar outcomes arise because students share environments or are selected in the same groups. So, for example, you might have common teachers, common curricula, school resources, or you are already sorted by abilities and motivation as in a tracking system. Yeah. So again, one effect is how I respond to the other peer outcomes. The second effect is how I respond to my peer predetermined characteristics, and correlated effects. These are mainly due to sorting by abilities. This is a standard model, how these peer effects are estimated. So on the left-hand side, again, you have some kind of student outcome, is a test score, and you have some individual characteristics denoted by XIC. So these are individual characteristics, your prior achievement and your socioeconomic status. There is a X minus 1C, which is the average peer characteristics, which is called contextual effect, and also average peer outcomes, which are endogenous effect. And delta is the variable of interest, but the problem that it is challenging because of simultaneity and sorting. And again, it's important to use experimental and quasi-experimental research designs for this purpose. Yeah. Any questions on the model with the peer effects? No? Okay, so again, like your outcomes, for example, the grade of Vladimir at school, depend on several factors, like Vladimir's previous achievement at school and your socioeconomic status, to which kind of family you belong. It depends on average peer characteristics. Let's say, what kind of students do you study with? From which socioeconomic background or from which prior achievement did they come from? And they also depend on average peer outcomes, some kind of endogenous effect. What outcomes have your classmates? Yeah. So there is some literature which states that if your peers have bad outcomes, you're kind of afraid sometimes at school to have good outcomes. I don't know if it does make any sense for you. No? For example, like students who perform much better than the average in the group might be kind of bullied because of that in kind of bad schools. Yeah? So that's why peer outcomes might matter for your outcomes. Or, for example, if you know that you study in a really bad school with kind of relatively bad students, then you don't really motivate much, you are not very motivated for academic achievement. Yeah. So I don't know if you studied in like a top good school or in a bad school. So yeah, it might depend. So there might be kind of school culture. In some schools, it would be really cool to to perform better than your classmates. A kind of competition, but a kind of a positive competition. But there might be schools where like 80% of your class are quite kind of bad, and when you perform too good, you can be kind of bullied. Haha, you are too smart, you're a nerd, something like that. So this can be a problem. That's why peer effects really matter, and they might affect your outcome. Consider, yeah. So this is what peer effects is about. This can happen also in this group. Okay, you see, you have only 7 or 8 students. They don't really attend classes that often. Maybe you see, okay, they don't attend, why should I attend? Finally, we have 3 students here, right? So it's like, it's interesting. I mean, so for example, for the next course, for the course next year, I would suggest to change the curriculum and create more incentives for you to attend lectures. For example, to make a test or exam based on lectures, because we discussed with Jan this stuff. Yeah, because you don't tend to attend lectures much. So this is how peer ethics work. Do you have any personal experience with like how did you respond to your school environment? Do you have a good school or like mixed? Were you a top student or not?
I was a very bad student, but I went
Bad. You were a bad student, or
yeah,
you were a bad student? Okay.
but
What happened?
no, I like in school I had very bad marks and grades, but I went to a private school, so I was like, yeah, in a very small group with people that are not mostly also like in a higher like socioeconomic.
Okay. So you have a positive peer ethics,
Yeah.
but you created the bad peer
Yeah.
ethics for other students.
Yeah, I would say so.
Okay. Hannes, and you?
Yeah, I went to, I would say, normal school, so it was not the best school, but also not a bad school, but it was a gymnasium. We come back to the tracking, and I think most of the students wanted to study afterwards, so pursue kind of this academic path,
Okay.
which made you like already look out for university students to check which grades do I need to have to do this schedule and all that. So there were definitely peer effects. Because if everybody around you wants to go to university, you also want to, and you will, yeah.
Okay, exactly. So you see from this model, your outcomes depends again, like you are good, for example, you are predeterminedly good. Then like your peers are good and they also perform good. So this is why like this model makes sense. Gefei, and for you?
Yeah, my school is good in China that time, and it's kind of like the first high school in my hometown in etc. Yeah, but yeah, okay. There are several pair effects which you can perceive like different access to the degree of universities. But kind of recent, for example, like university, I don't know whether that will count into or not actually. But
No, it depends. Like, do you have a bad or good classmates, for example?
okay. I usually ignore the pair effects because I think that is much more to influence the own study and etc. So I can kind of sometimes do not really focus that much on
Okay. Okay, fine. Then, yeah, we can look at the evidence about in the literature on peer effects. So it is, I highly recommend, there is a handbook of economics of education where many topics are covered in detail. There is a kind of survey paper of Sakerdot. He wrote about peer effects. And so peer effects, he found that peer effects in school exist, but are generally moderate in their magnitude. But it's interesting that they are not linear. This means that low achieving students, like kind of bad students, may generate very strong negative externalities. So if you have like all the good students, but then you have two bad students or hooligans, whichever, that will create very bad externalities for the class. But positive effects of high achieving students are not that strong. So if you have like a group of bad students and you put two good students, it doesn't mean that these two good students can kind of improve the overall group dynamics. No. On the other hand, it means that these two students will perform worse due to peer effect. Yeah? And it's also interesting that for the peer effects, these effects tend to be stronger for behavior, effort, and disciplinary outcomes than for test scores. So, for example, if your classmates tend to drink alcohol during or smoke something, etc., then it's more likely that you will also do this. So it does not necessarily will affect your academic outcomes, but it definitely might affect your behavior. So this is an interesting finding from that. Yeah. Then also there should be kind of credible identification, as usual, which should be based on random or quasi-random variation in peer composition within the group. Yeah, and the other thing is that group formation policies can create some spillovers and influence educational equality, even without changes in school input. So it's important how you make the classes. Do you unite like the best students in one class, or you kind of have even in gymnasium, if you track students, but still in gymnasium you can have a different class policy because they are always like top students and like a bit lower performing students. And it's important how do you make the class. Do you put like all the top students in the one class, or you kind of distribute them more or less equally? Especially it makes sense in the systems without this tracking. Because so if you are in the system without tracking, then you might have a segregation by class. So for example, in Russia, we don't have a tracking system, but instead we can have a kind of segregation by class. So let's say we have like 10 classes in some grade, and so first two classes are strong, and like the last worse and worse and worse. Yeah. So there's a kind of segregation. You put like the stronger students with the stronger students, poorer students with a poorer student. And then you can have also kind of a segregation, but even without this tracking system. So you can just segregate by the class. So what do you think is better to put like the strongest students with the strongest students, or make it more kind of democratic?
I would say, like you said, probably the negative externalities are stronger than the positive effects. So I think to some extent it's important to segregate in intra-system, I'd say, but I'm not a fan of the tracking. But yeah, to some extent you need to intelligently sort the classes, I think.
Yeah, but you see that it's very crucial how you compose the class, because you study for 10 years or for like 8 years with different people, and if you study with like bad students, that can really affect your learning outcomes a lot.
Yes.
Because you tend to like smoke something, or you tend to drink something, your behavior will be different, but also it might also affect your academic achievement, but to a less extent it shows, but theoretically it can have an effect on that, right?
Yes.
So it's really depends with whom do you study. Yeah? Okay. So, a kind of summary. Education production function provide a framework to analyze how educational outcomes are produced from multiple inputs. So we discussed what would be the inputs, is the capital, equipment, materials, school, etc. It is labor, like teachers' labor. Key school inputs might include teachers and also class size, because class size matter how teachers' labor is allocated. Instructional capital and school resources as well. But when we consider this model, like this A is a function of the capital and teacher's labor, it is very simplified. And in reality, it also depends on like family backgrounds, it depends on your initial abilities, and it depends on peer ethics. And each of these factors is important if each factor matters. So peer effects, your initial abilities, and family background. And this might affect your outcomes. Causal effect estimation is quite challenging because there is always problem of non-random assignment and sorting. And it's important when you analyze this school economics and education production function that you use causal methods like RCT, DFID, RDT, or IB. And for the main outcomes like smaller classes improve achievement, especially for disadvantaged students, and family backgrounds, peer effect, and tracking are the key drivers of inequality. So there is always a trade-off, like are we interested in the efficiency or in kind of more equality? Because sometimes efficiency doesn't mean equality, right? So if you put the strongest students in the same group, and so yes, they will perform much better, but on the other hand, you can create a lot of educational inequality. Yeah. So this is a literature, kind of additional literature you can read about this topic, like Mansky, or Sakerdot, or Hanushek, or Hanushek-Gersman about this educational tracking. This is what was presented by Hans. Okay, so do you have any questions on the lecture material first, or on what do you have to do next week? Because next week you have to present an early draft of your research proposal.
No, I thought it's today.
No, it's next week.
It's next week. Because, okay. Because on Blackboard it's the 5th of January.
Let me check.
I mean, I'm fine with it being next week. I'm like.
Okay. They should be here.
No, it's January 12th.
Yeah, I have the old syllabus then.
Yeah, but we said it was preliminary, and yeah, we have to update it. Okay, so you have to, but it's good, you already prepared, right?
Yeah.
Okay, so any questions on that presentation? What do you have to do? No.
I mean, how the like should we already have like the functions and the commands for data, something like that, or
Like the higher degree of preparation is already done, the better for you. But I mean, in general, the idea is that you present your research idea. Data, it's important because you need to kind of merge this research idea with the data. Otherwise, it's not doable. Yeah? And maybe you could also prepare a kind of initial model.
so functional.
Yes, a kind of a model you wanna use. Yeah, and then we can discuss if it's doable or not, what could be the details, and so on and so forth. And for a replication, it's a bit different. You have a replication, right?
Yeah. I
So-
also need to run the code. run the code, but I will do this before.
Okay, because as we discussed for application, there are two things. First, you need to check if this code can be run and produce the same results. If not, then then it's really cool. You can write to the journal and maybe publish it, right? That like you kind of find a contradictory results. But also you need to have a kind of a plan, what you're gonna do, how you're gonna kind of do other types of robustness checks, if there is space for that, because sometimes everything is already done, because like you have good reviewers, you have good authors who publish, you really need to think what kind of checks, robustness checks you're gonna use. Okay? So, if there are no other questions, then probably we could finish at this point, because we have only one presentation to that instead of two. And yeah, and Happy New Year again. See you next week.